Hi, welcome to this video, Unit 2, Lesson 2. We're going to be talking about conditional statements. All right, a conditional statement is a statement that can be written in if-then form. It doesn't have to be, but it can be. So a simple conditional statement that we might use here is if it is raining outside, then the ground gets wet. Okay, so if it's raining outside, of course, the ground is going to get wet. The if part of that conditional statement is called the hypothesis. It's the part after the word if. If is not included in the hypothesis. So this is the hypothesis. Different than the use of the hypothesis in science class. So we have to keep our context going here. The then part of the statement is called the conclusion. So it's the part that comes after the word then. And sometimes we just underline that twice so you don't have to write the word conclusion. But in our notes, we should write it once. So we know that underlining one time means it's the hypothesis. Underlining two times means it's the conclusion. Conditional statements can be written with the word implies, noted by, I thought I had fixed that typo, the symbol, which is like an arrow kind of symbol. Okay. So P implies Q is the same as saying if P, then Q. And P and Q would stand for some real world event. So if we look back at our example up above, let's say I let the hypothesis it is raining outside be called R, and the ground getting wet, the conclusion, be called W. So I could rewrite this as R implies W. So if it is raining, then the ground gets wet. Or raining outside implies the ground is wet or gets wet. A conditional statement is only false if a counterexample can be produced. And we covered counterexample in our last statement. A counterexample makes the hypothesis true and the conclusion false. So if I could find an example somewhere of it raining and the ground outside not getting wet, then I could prove that that is a false statement, which we can't. Whenever it rains, the ground gets wet. I mean, yes, you could have an umbrella, but that's only going to protect a small portion. The ground somewhere is going to be wet. So that's why that would be classified as a true statement, because no counterexample exists for that. Whereas we could come up with a conditional statement where we could find a counterexample, and we will in this lesson. So what we just did is classify the statement as true. We call that the truth value of the statement is saying whether the statement is true or false. So that's what that is. Okay, so in these next few examples, we are going to identify the hypothesis and the conclusion, and then we will classify the conditional as true or false. So the first statement says, if you have all A's in your classes, is going to be the hypothesis. You will be on the honor roll at SMS is going to be the conclusion. And that is a true statement because it is a rule in this building that if you have all A's, of course you're going to make the honor roll. I think you can even have not all straight A's and make honor roll. All right, the second one, vertical angles are congruent. That one is not written in conditional form. So what we need to do is rewrite it first as an if-then statement so that we can say, what the hypothesis and what the conclusion are. So I'm going to rewrite that. If two angles are vertical, then they are congruent. Okay, so now I can identify what the hypothesis and conclusion are. There's our hypothesis, two angles are vertical. There's our conclusion, they are congruent. And yes, you could write it in symbols. Let hypothesis be V for vertical angles and conclusion be C for congruent. And that is a true statement. It is one of the rules that we've learned so far this year in our first unit that when you have two angles that are vertical angles, they are the same in measure. Okay. Now we could do the first one and go back and do it in symbols if we want to. If you have all A's in your classes, we're going to let that be represented by A. Then you will be on the honor roll at SMS, HR. So having A's implies honor roll. So we can write it there. All right. If an animal is a unicorn, then it has a large horn on its forehead. Okay. So an animal is a unicorn is the hypothesis. Having a large horn on its forehead is the conclusion. This statement we have to classify as true because you're not going to be able to find a unicorn that doesn't have a horn on its forehead or a large horn on its forehead because unicorns don't exist, so we can't classify it as false. Let me just give you an example of a conditional statement that would be false, okay? If a polygon is a rectangle, then it's a square. Okay, so this is the hypothesis. Being a square is the conclusion. And that is going to be false because I can give you a counterexample of a polygon that is a rectangle, but it's not a square. Here's one right here. Here's a rectangle with our 4 right angles and our opposite sides equal. But it's not a square because in a square, all 4 sides are the same length. So that is false, and there's your counterexample. Okay, the negation of a statement is the opposite of it. So when you say something is not true, saying the opposite of that would be saying it is true. Or if you are saying something that is true, saying the opposite of that would be saying it's not true. So let's say, for argument's sake, we have a statement, two angles are congruent, that I'm letting be A. The negation of that would be the two angles not be congruent, not A, and that little squiggly, the tilde symbol, is used as a negation here. Now, I know it's part of the congruent symbol. Oops, I slid my screen. It's part of the congruent symbol that we had in the previous lesson, okay, because this means the word similar, and this means the word equal. Similar shape, equal sides. So we are going to be using this symbol in 2 places this year, and you'll just have to look at the context to decide if we're using it to mean negation or if we're using it to mean similar. All right, so we talked a lot about what a conditional statement is. Now we're going to talk about the ways that you can change up a conditional statement to get other what we call related conditional statements. I don't want this here because we're going to be writing that on our own. All right, so the first thing you can do is if you switch the hypothesis and the conclusion, they're interchanged, you get what's called the converse of the conditional. And we have a conditional here. If an angle measures 73, then it is an acute angle. So I'm letting 73 imply acute angle. So this is represented by 73. This is represented by acute angle. This is true. An angle that measures 73 is an acute angle because by definition it has to be less than 90 to be called acute, and 73 is less than 90. So we're going to switch it around, but you don't have to switch all the words. It's not like a formula that you take something and you just slide it to a new location. You can keep some of the words, but switch what we call the essential meaning. The measuring 73 is the essential meaning of the hypothesis. The being an acute angle is the essential meaning of the conclusion. We know we're talking about an angle, but it's the 73 and the acute that are the important part. So for my converse, I'm going to write if an angle is acute, okay, I'm switching, then it measures 73 degrees. That's going to be a false statement because if an angle is acute, it doesn't have to measure 73. It can measure anything else smaller than 90, like 52 or 40 or whatever. So that's a false statement. So converse is switching the hypothesis and the conclusion. The next related conditional statement, and there are only 3 of them, is the inverse. When you write the inverse of a conditional, you keep the hypothesis first and the conclusion second. You don't switch them like we did with the converse. We don't switch them. Inverse, you negate and you keep them in the same order. So you say the opposite of what is there. So our original statement says if an angle measures 73. So we're going to say if it doesn't measure 73, then it is acute. We're going to say if then it's not acute. If an angle doesn't measure 73 degrees, then it is not acute. Oops. If an angle doesn't measure 73, then it is not acute. So I negated both parts. Now that's false because we can have an angle that doesn't measure 73, but is acute, like 52. And then last but not least, we are going to talk about the contrapositive. That is when the hypothesis and conclusion are switched and negated at the same time. So you're doing the inverse and the converse at the same time. So I'm going to take the original sentence and I'm going to start with this. If it is not an acute angle, then it does not measure 73. Yeah. Okay. So if an angle is not acute, then it does not measure 73. Well, that's true because if it's not acute, then it can't measure something less than 90 because 73 is less than 90. So I'm going to say that one is true. Okay. So what I'm going to do is stop this video here and make a second one because I don't want to run against my time that I'm allowed to record. And the second video will follow up with this one and we'll finish the lesson, continuing with our conditional statement examples and talking about biconditional statements.